So that's it, that's maintenance done. There's not much to talk about other than it's a painful thing to do. So then there's all these new extra features that I like to keep adding. And so one of the most useful things that I've been adding recently is the ability to link your node network to some external files. So some of you will know a bit about the model, some of you won't know so much detail, but basically you can use this graphical tool to create your network model. And so here I've got this is representing a tall building with stairs, and I'll come back to the stairs in a minute. And you draw, each of these represents part of the stairs, and you need to put in dimensions. How big the node is represents the space. So here I've got 30 or 40 floors. Actually, the biggest one I've got is 52 floors. And so you have to type in the dimensions in each node. You go all the way down, type it in. So you type the numbers into here, go to the next one, type it in. And then you might get to the point you think, I haven't quite got the dimensions right. So what you have to do is go and load up the file, type all the numbers again. Very tedious. So what I've done is said, well, maybe I can link that to an external file. So what I can do here is have it so that I only change the dimensions once in an external file, and then I link that external file to each node, and it reads in the information and populates those. So this means it saves I only have to change the file once, change the dimension once, and all 50 floors will change automatically when the model runs. So I create this file with the dimensions in. I put the file into the into a folder somewhere, and then I basically link it here with a URL that says go and read this file, and every one of these will read in the data, and it saves me doing lots and lots of typing. I always say there's a fine line between laziness and efficiency. I'm quite lazy. The minute there's something that takes, I think, oh, this is going to be really boring, it's going to take hours to do, I'd rather spend the hours coming up with a fancy way to do it than just doing the mechanical typing. I hate doing mechanical typing in things. So it works quite well. The only problem is something we call memory leaks. And this is go back to this compiler problem, is that every time I do this, it allocates some memory to read in some of the information, but for the life of me, I can't work out how to release that memory. I should be able to. The program should be allowed to do it, the compiler, and I've spent days scratching my head trying to figure out how to do this, to the point where I just kind of gave up in disgust. So it's one of these things that I know needs to be cured. I mean, the model still runs, but if you run this in Monte Carlo mode and run thousands of simulations, the computer will run out, at some point it will just crash, because it will say there's no more memory, and it will just fall over. And it's very annoying, but I don't know how to cure it at the moment. My programming skills are clearly not up to it. The other thing that's quite useful, and this came about particularly when those guys, you remember Rick, when he was doing his work, was you type in all these dimensions, and then you run the model, but then you think, oh, have I got all the dimensions correct? And you have to go back in and click on each box and look at the numbers, and you think, well, this is not a very efficient way of doing it. So what I've done is create a way that when you create an output file, it will tell you all the dimensions that you've set. It will tell you whether you've set a door, an opening, or other things. So now you can visually just look at all the dimensions and check that you've got it right, rather than having to go through and click all your dimensions one by one to look. So this is a real time saver. Again, it's just about making things more efficient in terms of your documentation. I've been playing around with the different exit algorithms. At the moment, there's about 9 different algorithms, and the one that's mainly used is what we might call the minimum distance. So you imagine you're doing an evacuation, and you know a building, you generally will think about, well, which is the quickest way out in terms of travel distance. I've created a bit of a complex node here just to test it out. So if a person starts up in room 1, then the minimum distance to the nearest exit will be this part here, because it's a total of 6 meters. If they went this way, it'd be 12 meters. So it's partly showing how you can create this more complex node, and I'm checking the algorithm. But when Rick, and particularly again when Rick was doing his stuff, and those guys, I don't think there's anyone here when we did the, when Dave Purser was here and we tried doing the station nightclub, it would have been nice just to say, just direct a certain number of occupants to a specified exit without having to worry about these other algorithms. So I basically created what I call a minimum distance to specified exit algorithm. So now you can say, I just want this person to go to a particular exit, but for them to find the shortest route. So in this case, if I tell this person starting up here, this agent, that I want to go to exit 2, then when they get to here, although this is 2 metres this direction, from there on they say, no, I want to go to exit 2, it's 10 metres, so be it, they walk for 10 metres. So just different algorithms. Now I'm trying to develop a few more algorithms in terms of exit choice, but we won't go into that. And then from there, in terms of output visualization, so we've got that output visualization where I can output a single diagram with the dimensions. And I thought, now I can do something a little bit more useful than that. Because in the end, when you're doing any of this modeling, you want to document what you've done. You want to be able to produce a report that says, here is my inputs, which you might just put a great input file, but it's not very easy to read. But if you can show the input graphically, then that's quite useful for someone to read it. Quite useful for me to do a presentation. So it'd be nice to have some graphical output as well, rather than just getting Excel spreadsheets and plots. So from here, and it's not very easy to see because I've chosen this stairwell example, but you can have it so that you can plot for any given time step the number of people in each node. So now you can track where the people are. You can plot the percentage of agents in each node as a percentage of the overall occupation. So you can look at it in terms of there's 10%, 12% over here. You can colour in the nodes based on occupant density. So this is I think quite a nice way of looking at where there's constrictions going on. The colour of the node, the darker the node, the higher the occupant density. And that might be a useful way of kind of checking the model or visualising what's going on. And then you can also now create little dots that represent each individual occupant. And so if at a given time step, you can basically say, which node are the occupants in? Now, it doesn't mean that they're exactly in these positions, because I don't track exactly where each occupant is within a node, but at least it gives you some idea of where those occupants are. And the great thing about this wired output software is you can generate what they call them, you can generate GIF or GIF files. And then you can link a whole bunch of those together. Well, the other thing, you can combine all those outputs, so you can just do your dots and your grayscale and so on and so forth. But if you link all these GIF files together, or GIF, I call them GIF files, you can create little animations. So like the old days, I don't know if you guys ever, the school used to get a little flip book and put a little running man in the corner and flip the pages. Well, you're basically doing the same thing here. So you can see now, every 5 seconds or something, I've output these files, and then I just link them together into a kind of animation, which I think works quite well. Well, it's better than nothing. And then this is one I did when Rick was doing his work with his sports centre. So here I've got, I coloured in the nodes depending on which room they started, and he had different groups, so I give him a number. So now he could watch the animation and kind of see where certain people were going. You can see the red dots going into this room and then going and so on. I mean, you could look at each static image, or you can just look at the animation. So, and then you can it just runs the animation, and you can put it on a web page or whatever. Quite nice, really. And remember, I've been really fortunate finding this wired software, because it saves me a whole host of writing my own code to write inputs and outputs. That's laziness for you. There's a whole bunch of other stuff, which I'm not going to go through too much. Different types of connections, opening connections, whole different ways of defining stairs in terms of steps and heights and that sort of thing that will become obvious or evident in a minute while I'm talking about stairs. Those of you remember Darren Glasgow was down a couple of weeks ago, and he's doing this stuff with refuge floors. So the thing here is I've now got a function that allows you to, when an agent enters a node, they'll stand and wait there for a while, and you can set a probability distribution that they will wait or not. You can set a probability distribution of how long they wait. So this is all to do with this refuge floor capability. And the other thing is, I've had this functionality that allows you to designate routes that are either preferred routes or fire exit routes, so to allow you to sort of model some of that behaviour. And now in Wired, I've got it so that the user can colour in the connections, and it will automatically work out where these routes are. So it saves you having to type all this data in. You can just do it nice and graphically.